Here's another example of how to graph a trigonometric function. So this time we have y equals -2 cosine of 2/3 x. Now always the best place to start is by determining the initial and terminal x values that correspond to one complete cycle. And so just like we did with the last example, you take the argument, so what's inside the trig function, in this case 2/3 x, and put that between 0 and 2 pi. And again, the reason you do that is because the graph of just the parent function here, y equals cosine of x, you get one complete cycle as x goes from 0 to 2 pi. That's for y equals cosine of x. So when we've got cosine of 2/3 x, then we want 2/3 x to range from 0 to 2 pi. Now, to isolate x in that inequality, we should multiply all three parts of the inequality by the reciprocal 3/2. That way, you know, the 2's cancel, the 3's cancel, and you have just x in the middle. Okay, but if we do that to all three parts, I can just copy down what we had here, then okay, so we have 0 times, I'm going to leave myself a lot of room here, times 3/2, 2 pi times 3/2, and, well, 0 times anything is still 0. So there you go there. And then here the 2's cancel, and so you're left with 3 pi. So we're going to get one complete cycle for this graph as x ranges from 0 to 3 pi. Now you should set up your axes. And I'll go ahead and set them up right here. All right, 0 to 3 pi, so I'll just mark off increments of pi here. So here's 1 pi, 2 pi, 3 pi. It's fine if you don't label every single increment there, as long as you label at least one, so we know what your x values are. Okay, now solving this inequality takes care of any horizontal transformation, so we don't really have to think too much about phase shift and period. That's taken care of when you solve the inequality. You do have to consider any vertical transformations. So now we'd go back up and look at the original function and notice this -2 out front. So that's going to cause two things to happen. First of all, since you have the 2 there, that gives this graph an amplitude of 2. The other thing you see is the negative in front. That will reflect the graph. It'll flip it upside down. It'll reflect it over the x-axis. Whenever you have a negative out in front of your parent function, then that'll flip your graph upside down, which would be a reflection over the x-axis. Okay, now I think I'm going to take a step back and graph just with the horizontal transformations. So first, I guess I'll use blue. I'm going to graph y equals cosine of 2/3 x. So I'm ignoring the -2 out front for now. All right, so to plot that graph, I think about the graph of y equals cosine x up here. And the graph for cosine starts and ends at that maximum value of 1. Although it's nice to also note, well, I know the amplitude is going to end up being 2 when I do the vertical transformation, so I'm going to go ahead and label 2 on here. Okay, ignoring the vertical transformations, I'd have this thing start and end at 1. In the middle, the graph has this y value of -1 for y equals cosine x. In the middle, it reaches its minimum value. Okay, so I've got the interval from 0 to 3 pi down here. So the middle would be 3 pi over 2, which would be right here between 1 pi and 2 pi. So it would be 1.5 pi. So down here, oops, I'm changing the amplitude already. Sorry about that. I'm going to graph it with just amplitude 1 for now. So -1. Halfway between the, I'll give my pointer, halfway between the maximum here and the minimum here, you get an x-intercept. So that's going to be halfway between 0 and 3 pi over 2 would be 3 pi over 4. which would be about here. But I'm fine with it if you just kind of eyeball that and just mark the halfway point as your x-intercept, and do the same thing over here. Halfway between the minimum and the maximum is your x-intercept here. And draw, I didn't mean for this. Okay. And draw the curve through here like that. Okay, but again, that's this function. So one last thing we have to do is account for that -2. And this is some weird bug with this program. It just randomly makes my pen a little thicker here. We have to take that -2 into account. So like I said, that does two things. That's going to make the amplitude 2, and it's going to reflect the graph over the x-axis. So I'm just going to go point by point and make those things happen. Oops, okay. So this point right here, the pointer again, was at +1. So when I reflect it, it's going to be at -1, and then make the amplitude 2, it's going to end up down here at -2. So I'm going to plot that point down here. The same thing's going to happen over on this side of the graph. Right now it's at +1. We'd reflect it and give it an amplitude of 2, and it'd end up down here at -2. Okay. These two values, the x-intercepts, the y value is 0. Reflected over the x-axis, it's still on the x-axis. When you give it an amplitude of 2, you're multiplying the y value by 2, but if it's 0, then when you multiply by 2, it's still 0. So these points are going to stay, these two. And then the one last thing, so this point right here, the y value is -1, so when we reflect it, it's going to flip up to +1, and then make the amplitude 2. So now it goes up here to 2. And this, that I'm drawing in red here, this is the graph of the given function y equals -2 cosine of 2/3 x. So think about these in two steps. First, use the inequality to take care of your horizontal transformations, and maybe even graph just based on that, and then go point by point with your y values. You could just think of this transformation as multiplying each of the y values by -2, and that'll land you with this graph in red here.